The first thing you should think about when you see a differential equation is what type of differential equation it is. You need to classify that differential equation. So there's two ways to classify it. There's the order of the differential equation, which we'll see simply means the highest number of the biggest degree derivative that's in it, and whether or not an equation is linear or nonlinear. So let's start with the easiest thing, the order. So the order of a differential equation is just the highest derivative in that equation. So let's take a look here. I've got y prime, this first one says first order because it's y prime equals 3y plus 3. It's a first order because the highest derivative is 1. The second equation is second order because of the prime prime. So that makes it a second order equation. If I look at this third one, I got a prime, I got a prime prime, I got a prime prime prime. So it's a third order differential equation. The last one, that's a first derivative, second derivative, that's no derivative. It's a second order because of the highest derivative. So the order of a differential equation just means the highest derivative that's in that equation. Now solving, let's say, a third order differential equation is akin to integrating that equation 3 times. So you expect to get 3 constants of integration. There should be 3 constants. How do we get those constants? Initial conditions. That means that we can be given 3 initial conditions, like y naught equals a number, y prime naught equals a number, and y prime prime naught equals a number. So like what's the point when time equals 0 or when x equals 0, what's the slope there, and what's the second derivative or concavity, or acceleration if you're thinking about it as a distance versus time. But anyway, we'll have 3 constants and we get them with the initial conditions. The next thing to think about then is whether or not an equation is linear or nonlinear. Now, what we mean by linear and nonlinear, we mean linear or nonlinear in terms of y. So it's whether y, the dependent variable, is linear or not. So short story, or way to write this in a mathy way, here's a linear equation. A linear equation is some weighted sum of the derivatives, the nth derivatives of the function, the dependent variable, is equal to some function of x, the independent variable. Now this is not that helpful a definition when we first see it. We want to see some examples first. So, and the a's, they could be constants, constant coefficients, or those a's could be functions of x, of the independent variable. Remember, linear versus nonlinear means in terms of the y. So let's take a look at this first example. We said it was first order up here, but now I've got y prime equals 3y plus 3. It's linear because I can move that 3 over to the other side, that 3y over to the other side, and now I've got 1 times y prime prime minus 3 times y. I've got a combination of y and its derivatives equals some function of, well, in this case a constant function of x. So that 3 is in the g of x spot. A sub 1, the thing times the thing multiplied by the first derivative, is a 1, and the a sub 0 or a naught, the thing times the no derivative, or just a plain y, is minus 3. So we just put it into this form to show it's linear. Here's our second order. This is also linear because I can move that 3x squared minus y over. And I guess the point of this one is, x squared, that's a parabola. So you'd say, well, that's not linear. Yeah, but that's squared in the x. That's the independent variable squared. By linear versus nonlinear, we mean in the dependent variable. And as far as the dependent variable goes, the y's, it is linear. It's something times y prime prime plus something times y prime plus, I guess, 0 times y is equal to some function. So it's a second order linear. This next one, third order, we said, but it's nonlinear because, well, mainly because right here I've got two y's multiplied together, a y prime and a y prime prime prime. And there's no amount of algebra that I can do that's going to separate out that y prime and that y prime 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 so that I can make it into this form where I've got a linear combination of the y's. So basically I'm looking for things that are nonlinear happening to the y, and then I can classify it as nonlinear. Here, the last equation, that's nonlinear for a lot of reasons. It's nonlinear because I've got a y prime inside the sign. Here's a prime prime cubed. That's nonlinear. That's nonlinear. Here's the square root of y. Those are all nonlinear things happening to y. So that one's a nonlinear equation. The generally linear is easier than nonlinear. Generally first order is easier than second order is easier than third order, etc. We will, in fact, so let's look at, here's a first order linear. This is the general form of a first order linear. First order, so the highest derivative is 1. So I've got something times y prime plus something times y equals q. P and q both can be functions of x. It's in this form, but I guess you might say it's in this form, but I made the a sub 1 piece here 1. A better way to think about it is anything that was in front of the y prime, I divided it out first so that I put it in this form, y prime plus py equals q. All first order linear equations can be put in this form, y prime plus py equals q, where p is a function of x and q is a function of x. We're going to learn a technique to solve all of those first order linear equations, and the first step is put into this form. We'll also study in later chapters second order linear constant coefficient differential equations, equations that are of this form, ay prime prime plus by prime plus cy equals g. So in this case, constant coefficients means that the a and the b and the c are all numbers, they're constants. The g can be a function of x or t, but the a and the b and the c are all constants, and we'll learn how to solve all of these equations as well. So classifying them, that's our first step. Our first step in deciding which method to choose to solve them.